Alright, so MIT just dropped a paper on New Year's Eve that completely flips the script. And no, it's not a bigger model, it's not a wider window, it's something far more clever. Here's the thing. We've watched context windows explode from 8,000 tokens to 100,000. Then suddenly everyone's racing to 1,000,000. Sounds amazing, right? Unlimited context, infinite memory, problem solved. Except it's not. Because when you actually try to use these massive context windows in the real world, something strange happens. The model starts losing the plot. Literally. Quality tanks, answers get vague, costs spiral out of control, and the AI basically drowns in its own information. Researchers have a name for this now. Context rot. And it gets worse the more complex your task is. Simple searches where you're looking for one specific fact, those scale pretty well. But ask the model to analyze relationships across thousands of documents, or compare hundreds of data points, it falls apart completely. In benchmarks like Oolong, GPT-5's F1 score drops near zero, as inputs get longer. Near zero. That's not a context problem. That's a fundamental architecture problem. So here's where it gets interesting. A team at MIT led by Alex Zhang, along with Tim Kraska and Omar Khattab, just published a paper called Recursive Language Models. And the core insight is brilliant in its simplicity. Instead of cramming everything into the AI's brain all at once, what if the prompt itself lived outside the model? What if the AI could treat that massive input like a workspace it explores, rather than something it has to memorize? Think about how you'd handle a massive research project. You don't read every page of every book simultaneously. You skim, you search for keywords, you take notes, you focus on relevant sections, and sometimes you get help from colleagues to tackle different pieces. That's exactly what recursive language models do. The AI gets a simple toolkit. It can search through the input, pull out snippets, write code to filter information, and here's the kicker. It can even call smaller versions of itself to handle specific chunks. Then it synthesizes everything into one coherent answer. The results are honestly shocking. On a benchmark with up to 1,000 full documents, that's millions of words, millions. Traditional models can't even process that much input. RLMs handle it casually. GPT-5 wrapped in this system hits over 91% accuracy at under $1 per query. The old approach would cost up to $3, and that's assuming the model could even fit all that data in the first place. But the real magic shows up on harder tasks. Take code QA from Longbench. GPT-5 alone gets 24% accuracy. Add summarization, 41%. Switch to the RLM approach, 62%. That's not a small improvement. That's a paradigm shift. And what's wild is that even without the recursive calls, just moving the context outside the model's memory and letting it interact with it programmatically jumps accuracy to 66%. The environment itself is doing most of the heavy lifting. Here's what makes this so different. Traditional models are like students cramming for an exam, desperately trying to memorize everything. RLMs are like researchers with a library card. They don't need to know everything. They just need to know where to look and how to navigate. The model peeks at the input first to understand what it's dealing with. Then it searches selectively for relevant patterns. When things get complex, it breaks the problem into smaller pieces, sometimes delegating to helper models, and assembles the final answer step by step. Now, it's not perfect yet. Current RLMs only go one level deep. There's no reinforcement learning guiding when to split tasks or when to stop searching. Sometimes the model overthinks and burns through budget. But here's the thing. These runs are basically reasoning traces. And reasoning traces can be trained. Combine this structure with RL, and you could teach models to navigate massive inputs efficiently, learning exactly how deep to recurse and when to move on. Prime Intellect has already built on this idea with their implementation, adding batch processing and strict output formatting. They've tested it across web research with noisy pages, competition math problems, and complex data reproduction tasks, and the pattern holds. Models become dramatically more reliable once wrapped in this structure. But they also discovered something fascinating. Different models behave completely differently inside the same RLM framework. GPT-5 is cautious and selective, Qwen 3. Coder is aggressive, splitting things line by line. Same system, totally different strategies. For the longest time, progress meant bigger models, more data, more compute. RLMs add a completely new dimension. The limit isn't how much fits in the context window anymore. It's how well the model can navigate information that lives outside of it. We're talking about agents that could handle entire company knowledge bases, massive code repositories, months of logs. all without forgetting critical details. And we're already seeing it work at 10 million tokens and beyond. So is this the future? Is the context window race officially over? One thing's for sure. We're not just making AI smarter anymore. We're teaching it how to think about information itself. And that might be the bigger breakthrough. So, is this the end of context? Windows even mattering? Drop your thoughts in the comments. Share with your friends. And if this helped you understand what's really changing under the hood, hit like, subscribe for more deep dives like this, and thanks for watching.